Beneath the blazing equatorial sun, the Pacific waves stretched endlessly, white crests trembling against the horizon. Soldiers and engineers moved like shadows across the coral-strewn beaches, boots crunching over jagged fragments of reef. The roar of distant artillery mingled with the hiss of landing craft, engines sputtering against the tide. In the heart of this raw, untamed landscape, a plan was unfolding that defied expectation. American engineers, burdened with steel, timber, and unrelenting heat, began carving a runway from living coral. Every hammer strike echoed across the lagoon, every diesel engine shuddered the sand beneath. Japanese lookouts could not fathom the speed, the audacity. In 3 days, what was once a jagged reef would become a fully operational airfield, a platform for bombers and fighters, a pivot upon which the war in the Pacific would turn. Nature and ingenuity collided, and the world watched, stunned. In early 1944, the Pacific theater was a crucible of strategy, endurance, and relentless logistics. The United States had embarked on an island-hopping campaign, seeking to bypass heavily fortified Japanese positions and secure airstrips closer to the Philippines and the Japanese home islands. Each island presented unique challenges: dense jungle, sweltering heat, unpredictable tides, and reefs that tore at the hulls of landing craft. Intelligence reports had identified a small, seemingly insignificant atoll in the Central Pacific as ideal for an airfield. Its location offered range to Japanese supply lines and the ability to launch strikes against enemy garrisons. Yet the island was a coral-strewn labyrinth. Its beaches narrow, its interior covered with jagged outcrops and shallow lagoons. Conventional engineering methods were impossible. Every heavy vehicle risked being stranded on the reef. The task required speed, precision, and innovation, for Japanese air reconnaissance and patrols constantly threatened the operation. Assigned to the mission were units of the Navy's construction battalions, the Seabees, trained in both combat and rapid construction under hostile conditions. They arrived under a blistering sun, carrying drills, bulldozers, steel mats, and explosives. The men faced immediate obstacles: uneven coral, dense undergrowth, and shifting sands that swallowed equipment. Supplies had to be ferried in small waves of landing craft, often under intermittent enemy fire. Yet, they worked with unwavering discipline. Each day began before dawn, hammers and saws clashing with the hiss of diesel engines and the slap of waves. They cut through living coral, blasted and leveled it, and laid the foundation for a runway designed to support fully loaded bombers. Every inch gained was a testament to coordination between engineers, infantry providing security, and naval logistics ensuring a continuous flow of materials. By the second day, the skeleton of a runway emerged from the coral, an improbable line stretching across the reef. Observers in the surrounding waters noted the efficiency, noting how the men moved seamlessly between tasks, adjusting plans as tides and winds shifted. Engineers reinforced sections against erosion, compacted coral into firm layers, and built drainage channels to prevent flooding during sudden tropical downpours. The airfield's design considered not only immediate functionality, but survivability under enemy attack. Planes would arrive within hours of completion. Yet every nail and layer of coral had to withstand the shock of landings, the vibration of engines, and the threat of bombing. This operation would not only test the Seabees' technical skill, but their resilience, endurance, and ingenuity, under conditions that would break lesser units. The island was a natural fortress of jagged coral, heat, and surf. But within its boundaries, human determination began to shape the impossible into reality. The Japanese garrison on nearby islands monitored the Central Pacific atolls with a network of observation posts and patrols. Yet, The speed of the Seabees' work caught them unprepared. Reconnaissance planes spotted the flashes of machinery and the linear outlines of cleared coral. But reports underestimated both the scale and the pace. By the third day, the airfield was no longer a sketch on a map. It was a tangible strip of hard coral, wide enough for fighters, long enough for bombers. Every aspect of construction had been adapted to the environment. Bulldozers were fitted with wide tracks to avoid sinking, coral fragments were pulverized and compacted into runways, and temporary revetments were erected to shield equipment from potential strafing. Soldiers and engineers shared the same rhythm, coordinated by hand signals and shouted commands above the roar of engines and surf. The heat was relentless. Sweat-soaked uniforms and burned eyes. Yet no operation was paused. No task left incomplete. By the end of the third day, the first reconnaissance aircraft prepared for landing. Navy pilots, briefed on the novel construction methods, marveled at the firmness and precision of the coral surface. The airfield, born from jagged stone and sweat, would now serve as a forward base, extending American air power thousands of miles closer to Japan. Strategists understood the broader significance. Control of the air allowed protection of amphibious landings, interdiction of supply lines, and direct pressure on isolated Japanese garrisons. The airfield was not merely a feat of engineering. It was a turning point in operational reach. Medical units, supply officers, and maintenance crews moved in immediately, establishing a fully functional support network. Fuel, ammunition, and spare parts arrived by small craft, distributed along the hardened coral by teams working in precise formations. Every structure, from revetments to storage depots, reflected a philosophy of rapid construction under fire. Even the approach to the airstrip was leveled and marked, ensuring maximum safety for aircraft on landing. Tropical storms threatened, but drainage systems and careful grading prevented significant delays. Engineers studied tides and coral hardness, adjusting layers of compacted stone with mathematical precision. By dusk of the third day, the entire complex gleamed under the Pacific sunset. A marvel of logistics, planning, and execution. Word spread rapidly among U.S. forces in the region. Reports emphasized not only the speed, but the audacity of transforming living coral into an operational airfield in 72 hours. Japanese commanders were stunned. Conventional wisdom held such terrain impossible for heavy aircraft. The success became a blueprint for subsequent operations, proving that engineering ingenuity could overcome natural obstacles faster than enemy forces could react. This single act of construction reverberated far beyond the tiny atoll, reshaping expectations of what could be achieved in the Pacific War. The first angle examines the unprecedented engineering innovation that made the airfield possible. Traditional airstrip construction relied on level soil, reinforced by concrete or steel, a process that could take weeks under ideal conditions. On the coral atoll, these methods were unworkable. The Seabees adapted swiftly, using explosives to break up jagged coral and heavy rollers to compact it into firm layers capable of supporting aircraft weighing tens of tons. Bulldozers moved with wide tracks to prevent sinking, while cranes and pulleys positioned steel mats for immediate landing surfaces. Every calculation was precise. The thickness of coral, the angle of compaction, even the timing of work relative to tides and wind. Engineers documented each step meticulously, producing a repeatable method for other Pacific islands. The ingenuity extended beyond machinery. Crews recycled coral debris, creating makeshift roadways and revetments that protected against erosion and strafing. They integrated drainage channels to handle sudden tropical downpours, ensuring planes could land safely even during storms. The speed of work astounded observers. Journalists embedded with the units noted that within 72 hours, a reef became a runway. an obstacle transformed into opportunity. Strategically, the innovation allowed American forces to leapfrog Japanese defenses, turning islands that were previously unusable into forward bases capable of projecting air power across vast stretches of ocean. The second angle focuses on the human dimension of the operation. The Seabees were not just engineers. They were soldiers under constant threat. Japanese patrols, occasional air raids, and the unforgiving environment created a high-stress setting where discipline and coordination were critical. Temperatures soared above 90 degrees Fahrenheit. Salt spray stung eyes and skin, and the constant clang of tools and engines created a cacophony that never ceased. Men worked in shifts, their movements synchronized like clockwork, responding instantly to changing conditions. Exhaustion was relentless, but so was resolve. Medical reports from the unit noted cases of heat exhaustion, minor injuries from tools, and tropical infections. Yet, absenteeism was minimal. The psychological toll of constant vigilance, knowing that any moment could bring enemy fire, was compounded by the need for extreme precision. Despite this, morale remained high, bolstered by a clear sense of purpose. Officers and enlisted men shared the same mission: transform an inhospitable reef into a strategic airfield. Letters from soldiers later described the surreal sight of planes landing on a strip carved from living coral, a moment of triumph that contrasted sharply with the physical suffering endured. The operation demonstrated that human adaptability, combined with technical skill, could overcome seemingly insurmountable challenges, producing results that would redefine engineering expectations in wartime conditions. The third angle highlights the tactical significance of the airfield in the broader Pacific campaign. By early 1944, American planners recognized that controlling forward air bases was essential for sustaining momentum across the Central Pacific. Japanese forces relied heavily on inter-island supply routes, and even small atolls could serve as early warning posts or staging areas for enemy aircraft. The rapid construction of the Coral Airfield shifted this balance. Fighters and bombers could now operate from positions previously considered inaccessible, extending the reach of reconnaissance missions, interdiction strikes, and close air support for amphibious landings. Naval and ground commanders noted the operational flexibility gained. With a runway in place, aircraft could refuel and rearm close to the front lines, reducing response times from hours to minutes. The airfield also served as a deterrent. Japanese reconnaissance flights reported the transformation with disbelief, recognizing that American forces had turned a natural barrier into a forward base capable of launching repeated sorties. This capacity to act faster than the enemy could anticipate forced Japanese commanders to adjust their defensive strategy, stretching resources thin across multiple islands and weakening concentrated garrisons. The fourth angle examines the logistical orchestration that enabled the feat. Every hammer, every bag of cement, every bulldozer had to arrive on schedule despite limited shipping and constant risk from Japanese submarines and aircraft. Naval transport units coordinated with construction teams to offload supplies in waves, navigating coral reefs and shallow waters that could strand even lightly loaded landing craft. Fuel for heavy machinery, fresh water for personnel, and medical supplies were distributed efficiently across a compact, chaotic environment. Engineers developed improvised systems to move heavy loads across uneven terrain, from hand-drawn carts to temporary tracks laid over sharp coral. Communication was maintained through a combination of runners, signal flags, and radios, ensuring that progress continued despite unexpected challenges. This intricate choreography reflected not only planning but adaptability. When tides rose faster than expected or equipment broke down, teams adjusted instantly, redistributing labor and materials without halting construction. The operation became a case study in wartime logistics, demonstrating that speed and precision were achievable under extreme conditions when engineering, planning, and discipline converged. The airfield was no accident. It was the product of meticulous orchestration and unyielding execution, transforming coral, sun, and sweat into a strategic asset that would shape the Pacific War. Dawn broke over the atoll, and the first operational sorties prepared for takeoff. Engines thundered, propellers sliced the humid air, and the coral runway, hardened through days of relentless labor, bore the weight of fully loaded bombers. Pilots reported a surface firmer than expected, the seams between compacted coral and steel mats invisible under the morning sun. Anti-aircraft crews remained vigilant, scanning the skies for the inevitable Japanese response. Intelligence indicated that enemy reconnaissance had observed construction, yet no immediate counterattack materialized. The tension was palpable. Every soldier, every engineer understood that the success of the airfield could be measured in hours, in the safe landing and rapid deployment of aircraft. By mid-morning, the first combat-ready fighters taxied into position. The roar of engines merged with the hiss of tropical wind and the crash of surf against the reef, forming an almost symphonic backdrop to the unfolding operation. Each takeoff was timed with precision, ensuring that bombers could depart without congestion and return with minimal delay. Observers on nearby ships noted the seamless coordination. Fuel trucks moved along improvised lanes, maintenance crews performed rapid checks, and ordnance teams loaded bombs and ammunition with clockwork efficiency. The speed of deployment shocked even seasoned naval officers. What had once been a lifeless reef was now a hub of kinetic energy, an axis from which American air power could project across hundreds of miles of open ocean. The psychological impact on Japanese commanders was immediate. Reports from the field described disbelief and dismay. A natural reef had been transformed into a platform for offensive action in 72 hours, defying conventional expectations of engineering limits. Japanese reconnaissance aircraft attempted low-level passes to assess the situation, only to reveal their presence to vigilant anti-aircraft gunners, who tracked movements with disciplined precision. The airfield's existence forced rapid recalculations in Japanese defensive strategy, spreading their forces thinner and creating openings elsewhere in the Central Pacific. Strategists in Tokyo recognized that such rapid construction could no longer be ignored. Islands previously considered safe from air assault were now vulnerable, reshaping the operational map in real time. On the ground, engineers and soldiers alike experienced the culmination of their labor in tangible ways. The first bomber landed smoothly, tires crunching against compacted coral, sending a spray of fine white dust into the tropical breeze. Cheers were subdued, discipline remained, but the sense of accomplishment was undeniable. Crews immediately refueled and rearmed the aircraft for subsequent missions, demonstrating that the airfield was fully functional under combat-ready conditions. Communications relayed back to command highlighted the unprecedented efficiency of the operation, offering a template for future island campaigns. The synergy of engineering, logistics, and military coordination reached its apex, proving that human ingenuity could bend the harshest natural conditions to strategic purpose. The atoll, once a remote and inaccessible speck in the Pacific, had become a fulcrum of power. From the roar of engines to the shimmer of sun on steel mats, from the hiss of wind to the crash of waves against the reef, every sensory element confirmed the transformation. Coral and sweat had been molded into a strategic instrument, and the consequences would ripple across the theater, redefining both expectation and reality in the Pacific War. As the sun climbed higher, sorties multiplied. Fighters launched in tight formations, bombing runs executed with precision, and reconnaissance planes scoured enemy-held islands, transmitting real-time intelligence back to Fleet Command. The airfield functioned not just as a landing strip, but as a forward node in an intricate network of operations, extending the eyes, ears, and striking power of the U.S. forces across hundreds of miles of ocean. Each takeoff and landing reinforced the psychological dominance of American ingenuity. A reef, once deemed untouchable, now projected power with the rhythm of engines and the discipline of men who had transformed it in days. Naval commanders observed the effects immediately. Enemy convoys diverted, supply lines disrupted, and small garrisons faced a new vulnerability. From the high vantage of carrier decks and observation posts, officers could see the efficiency of the airfield in action. Aircraft returned with minimal damage, quickly refueled and rearmed, and launched again with precision timing. Every movement, every engine roar, every drop of coral dust in the tropical sun testified to meticulous preparation. Engineers, medics, fuel crews, and ordnance teams worked in synchrony, their collective expertise enabling an operational tempo previously unattainable in the Pacific theater. Japanese responses were hampered by disbelief and miscalculation. Reconnaissance reports emphasized that the coral runway had been completed in an almost impossible time frame. Commanders debated whether the strip could support heavy bombers and hesitated to commit forces, buying American units crucial hours and days of operational advantage. This hesitation, born from underestimating both technology and human endurance, amplified the strategic impact. The airfield allowed fighter sweeps over enemy positions, disrupting patrols, isolating garrisons, and providing close air support for upcoming amphibious landings. The tactical reverberations spread far beyond the atoll, demonstrating that rapid construction under fire could shift the operational landscape without traditional sieges or prolonged campaigns. On the ground, engineers continued to improve and expand the facility. Revetments were reinforced, drainage systems optimized, and temporary hangars erected to protect planes from sudden tropical storms. The pace remained relentless, yet every measure contributed to survivability and sustainability. Soldiers noted in later reports that the line between construction and combat blurred. Each hammer strike, each compacted layer of coral, carried the weight of potential life and death consequences. Success was measured not in days alone, but in the seamless integration of human skill, mechanical power, and natural resources. By evening, the atoll had transformed completely. The once fragmented reef was now an operational airfield, radiating capability in all directions. Engines cooled under the setting sun, dust settled, and the horizon shimmered with the silhouettes of aircraft ready for the next day's missions. The feat was more than engineering. It was a demonstration of human adaptability, a declaration that even the harshest environment could be mastered with ingenuity, discipline, and coordination. In the Pacific, the war would never regard small islands or coral reefs the same way again. The immediate aftermath of the coral airfield's completion revealed both operational and strategic consequences. Within hours, American aircraft were flying sustained sorties over enemy-held islands, extending reconnaissance, bombing, and interdiction missions far beyond previous limits. Intelligence reports highlighted the efficiency of these operations. Bombers struck lightly defended garrisons, supply lines were disrupted, and Japanese defensive positions were forced to disperse in response to the sudden presence of forward-based aircraft. Pilots reported smooth takeoffs and landings, noting that the compacted coral withstood the weight and vibration of fully loaded bombers without significant degradation. Observers recorded the physical transformation of the atoll, emphasizing how an inhospitable reef had become a fully functional base, equipped with fuel storage, ordnance depots, and maintenance facilities, all within 72 hours of initial landing. Naval Command immediately recognized the broader implications. The Pacific Campaign had long been constrained by the need for secure airfields within striking distance of Japanese-held territories. Previously, engineers would spend weeks or months preparing islands, leveling soil, laying steel, and constructing drainage. The Seabees' rapid construction shattered conventional expectations. Future operations could now incorporate previously unusable islands into the network of forward air bases, allowing for accelerated campaigns and reduced exposure to Japanese counterattacks. Naval planners revised operational maps to include coral atolls and reefs previously considered inaccessible, redefining the range and flexibility of air power. The construction demonstrated that logistical mastery could be a decisive force multiplier, enabling aircraft to operate with unprecedented proximity to enemy positions. The Japanese military response was both immediate and disoriented. Reconnaissance had initially underestimated the scope of construction, assuming temporary clearing or minor improvements rather than a fully operational runway. Reports from Central Command noted surprise and concern. A reef transformed into an airfield within 3 days contradicted assumptions about American engineering capabilities. Tactical plans were hastily revised, defensive units redistributed, and supply lines rerouted to account for the newly established American forward base. The psychological effect on Japanese commanders was profound. They now faced the reality that static island defenses could be circumvented or rendered vulnerable by rapid, unexpected construction. The presence of forward air support forced garrisons into heightened alert, stretched their resources, and created vulnerabilities elsewhere in the Central Pacific theater. On the ground, Seabee units transitioned from construction to full operational support. Maintenance crews established schedules for aircraft servicing, fuel distribution was systematized, and ordnance teams maintained bomb stockpiles with precision. Medical staff treated minor injuries and tropical ailments, ensuring operational continuity. Engineers continued improving the runway, reinforcing vulnerable sections and extending taxiways for additional aircraft. Reports documented that despite extreme heat, salt spray, and ongoing operational demands, personnel maintained high efficiency. The coordination between engineers, pilots, naval support, and logistics teams became a case study in a wartime collaboration under extreme conditions. Each element reinforced the others, creating a resilient and sustainable operational hub that functioned continuously, day and night. Beyond the tactical and operational successes, the airfield became a symbol of American ingenuity and adaptability. Historians later cited the construction as an example of overcoming environmental challenges through innovation, precision, and discipline. Photographs and journal entries captured planes lined against the glowing coral, engines humming, dust rising under tropical sun. Evidence of a feat previously considered impossible. Within the military community, the operation inspired confidence in rapid construction capabilities, influencing doctrine for subsequent island campaigns, including those in the Marianas and the Philippines. The ability to establish airfields on coral and reef demonstrated that engineering skill could directly impact strategic initiative, shortening timelines and reducing exposure to enemy countermeasures. The long-term consequences of the coral airfield extended far beyond its immediate operational impact. Once established, the airfield became a linchpin for sustained offensive operations across the Central Pacific. Fighters and bombers based on the atoll could now cover distances previously unreachable without in-flight refueling, allowing strikes against supply convoys, isolated garrisons, and key infrastructure on Japanese-held islands. Intelligence reports noted a measurable increase in interdiction effectiveness, with supply shipments delayed or destroyed before reaching frontline positions. Reconnaissance missions returned with precise mapping, enabling subsequent amphibious landings to be planned with greater accuracy and reduced risk. The airfield's existence shortened campaign timelines and contributed to a cumulative attrition of Japanese resources and morale. From a logistical perspective, the operation became a benchmark for rapid construction under combat conditions. Military engineers studied the methods used by the Seabees, codifying techniques for compacting coral, creating drainage systems, and erecting temporary structures resilient to tropical storms. Manuals later included detailed instructions for transforming coral reefs and atolls into operational bases, extending the concept to remote regions where conventional runways were impractical. The success demonstrated that careful planning, combined with adaptability and rigorous discipline, could overcome environmental and tactical constraints, providing a blueprint for future operations in the Pacific and other theaters. Japanese assessments after the operation highlighted both surprise and concern. Intelligence briefs emphasized that American forces could now project air power from locations that were previously considered natural barriers. Commanders noted that static island defenses were increasingly vulnerable, and that rapid engineering feats could undermine strategic calculations. This recognition influenced defensive deployments, forcing the Japanese to spread their forces across a wider area, thereby diluting concentrated firepower and reducing the effectiveness of isolated garrisons. The construction of the airfield reshaped Japanese expectations of what the enemy could accomplish in both time and scope, creating a psychological as well as tactical advantage for the United States. Personnel accounts documented the human cost and endurance required to achieve this success. Engineers worked under extreme heat, salt-laden winds, and relentless operational pressure. Exhaustion was mitigated through rigorous rotation, careful rationing, and unyielding discipline. Minor injuries, tropical illnesses, and fatigue were constant challenges. Yet the cohesion and coordination of units ensured that progress never stalled. The airfield's completion was a testament not only to engineering skill, but to the resilience of the individuals who executed the plan under conditions that combined combat threat, environmental hazard, and logistical complexity. By the end of the first weeks of operation, the atoll had become a fully integrated component of the Pacific campaign. Aircraft conducted continuous sorties, intelligence networks expanded, and supply lines were secured and optimized. Strategists recognized the significance. Rapid engineering could redefine operational possibilities, and human ingenuity, applied with precision, could transform natural obstacles into strategic assets. The airfield's legacy persisted, influencing subsequent operations across the Pacific and serving as an enduring example of how innovation, discipline, and coordinated effort could reshape the battlefield. The construction of the Coral Airfield stands as a testament to the extraordinary intersection of human ingenuity, discipline, and determination. In 72 hours, a team of engineers and soldiers transformed jagged, inhospitable reef into a fully operational base, defying conventional expectations of both engineering and wartime logistics. The operation demonstrated that environmental constraints, no matter how formidable, could be overcome through meticulous planning, adaptive techniques, and relentless execution. Every layer of compacted coral, every improvised revetment, and every coordinated takeoff represented not just technical skill, but the resilience and endurance of those who labored under sun, surf, and threat of enemy action. Strategically, the airfield reshaped the Pacific theater. It extended American air power, enabled rapid strikes on Japanese positions, and forced enemy commanders to reconsider static defenses and logistical assumptions. Beyond the immediate tactical advantage, it became a blueprint for future operations, proving that rapid, high-risk engineering could decisively influence the course of campaigns. The psychological impact on both American and Japanese forces reinforced the value of initiative and innovation in warfare. Ultimately, The Coral Airfield exemplifies how skill, courage, and coordination can transform natural obstacles into instruments of power. It reminds us that history is shaped not only by the scale of battles, but by the ingenuity applied in moments of constraint and urgency. In the Pacific, a reef became a runway, and in doing so, it altered the possibilities of war, leaving a legacy that endures as both a strategic achievement and a human triumph.